Hello students, welcome to the third lecture of oscillation series on simple harmonic motion. Today I will discuss about the characteristics of simple harmonic oscillator. So far so good, we have studied that our stirring force is proportional to displacement and arcs in a direction opposite to the dot of displacement. We started here, set up the differential equation, reached here d square x upon dt square plus omega naught square x equal to 0. This is our differential equation of simple harmonic oscillator. Then we try to solve this differential equation and get this solution. X of t is equal to a cos theta plus omega naught t. You can yourself find another solution in a very similar manner. X of t is equal to a sin theta plus omega naught t. This is our cos theta plus omega naught t solution. You can find a sin theta plus omega naught t. ମୁଁ तुमको homework आकार छाड़ीथली, you can try. These symbols carry their meanings written here. X of t is our displacement of simple harmonic oscillator at time t. A is our amplitude of oscillation, which is nothing but the maximum displacement, the maximum distance covered by the oscillator from its mean position. And the most important one is theta plus omega naught t. What is this? This is the argument of this sinusoidal function cos. And this is known as phase of the oscillator, phase of the oscillation. That means phase is a new word for you. Phase means what? Phase means you can locate the position and direction of motion of the oscillator at any desirable time, at any instant of time. तुम जो समय चाहो सही समय oscillator location, position, direction of motion you can locate from here theta plus omega naught t. This is nothing our phase of the oscillation, and this is the argument of cosine function. X of t can be known, position of the particle can be known, position of the oscillator can be known from here. Argument of the cos function. We analyze these parameters to get some detailed information about our simple harmonic oscillator. Okay? So let's proceed. First, collect some information about the amplitude. What it is? Amplitude contour. In simple word, it is the maximum displacement on either side of mean position. That means if the oscillation starts here, and this position is x equal to 0, our mean position. I have already told about mean position. The position where net force on the oscillator is 0. And if you move towards this side, this is our x equal to plus a, also this side. From this to this, our oscillation is confined. Okay? This is plus a, this is minus a. Maximum displacement from here. Maximum distance covered from here, mean position, is our amplitude. Or you may represent it like this. This is a cos function, its graph will be. If you plot the graph, x versus t. X is function of t, na? You can plot a graph x versus t. Graph will be something like this, like this, like this. This one is your plus a, this one is your minus a, this is amplitude. This is amplitude. Okay? Now, at least you should recognize what amplitude is. And displacement is given by this equation. Now let's try to get some more information about amplitude. In some cases, if you consider two simple harmonic oscillators, these two oscillators may have same omega naught and theta, same omega naught and theta. Two stage superharmonic oscillators may have same omega naught and theta. Omega naught means what? Omega naught means if you are confusing, don't get any clear idea, then you should take it as time period. Omega naught is our 2 pi by t. Omega naught is 2 pi nu. You must have known this, or it's simply 2 pi by t. It means nothing. You can simply take it as time period. It is actually angular frequency. Take it as time period, so that you can get it very well. That means if two oscillators have same time period and at the same instant they are starting their motion theta, it means theta, with different amplitudes, it can be possible. It can be possible. Two oscillators start from same position at same instant, but with different amplitude. One oscillator oscillates within this region. This is plus A to minus A, like this. And other oscillators are covering some more distance, like this. It oscillates like this. Amplitudes are different, but they can take same time to complete one oscillation. Let's see how. Look at here. This is our x versus t graph. In first case, suppose our first oscillator has amplitude A and it oscillates in this manner, like this. Amplitude is A. And second case is, second oscillator is our having amplitude B and it starts oscillating like this. I am plotting the graph for cos. That's why I am starting here. B. Look at here. Time period is same. Time, first oscillator having amplitude A repeats its motion here. Second oscillator having amplitude B also repeats its motion here. That means these two oscillators have same time period, that means same omega naught, started at the same instant, that means same theta, but having different amplitudes. They can maintain it, they can manage it. Two oscillators may have different amplitudes, but these two oscillators can maintain their oscillation at the same time. You may think about this. How is it possible? Kemitically possible. जन एतिक डिस्टेंस कवर करछि तो तापाई टाइम जान एतिक डिस्टेंस कवर करछि तापाई भी टाइम से हम कहउछंती अल्टीमेटली वेलोसिटी ही किछि फरक आणथुबो एतिक डिस्टेंस कवर करछि जति समय लउछि एते डिस्टेंस कवर करछि से भी सेति समय लउछि ता माने वेलोसिटी पे किछि प्रोमिनेंट फैक्टर लिखउथुबो ता माने वेलोसिटी यार किछि ज्यादा हेतु यार किछि कम हेतु ओके नाउ यू गेट क्लियर आईडिया अबाउट दिस एंड सेकंड वन इज आवर same A and omega naught. We can take two oscillators have same A amplitude and frequency A and omega naught, but started at a different instance. At a different instance, they start oscillating, but they have same amplitude and same time period. They can take same time for one complete oscillation. Amplitude is same, but they start at a different time, at different instant. So I think you can look at here. Again, this is our XT graph. One oscillator starts here, having amplitude A. Other one is also have same amplitude A, like this. But look, this is the one extreme side. This is our plus A. But here the second graph, just look at the second graph like this. It is started here and its amplitude is here. Just look at here, then like this, then like this. Sorry, like this. What I will say? Two oscillators, one yellow color, other one is this color. They have same amplitude. Here amplitude is A, here also amplitude is A. But look at the instant. It is started here from one extreme side It is not started from the extreme side. ଧର ଗୋଟେ ପିଲେ ଆମର ଏକ୍ସଟ୍ରିମ୍ ସାଇଡ଼୍ରୁ ଆରମ୍ଭ କଲା ଏମିତି ଚାଲିଲା, ଆଉ ଗୋଟେ ଏକ୍ସଟ୍ରିମ୍ରୁ ଆରମ୍ଭ ନ କରିକି କେଉଁଠି ଟିକେ ପଛରୁ ଆରମ୍ଭ କରୁଛି, ତାପରେ ଏକ୍ସଟ୍ରିମ୍ କଭର କରୁଛି, ତାପରେ ଫେରୁଛି। କିନ୍ତୁ ଦୁଇଟା ଯାକ ଅସିଲେଟର ପିଲେ ସମାନ ଟାଇମ୍ରେ ଆମ୍ପ୍ଲିଚ୍ୟୁଡ୍ ସମାନ, ଟାଇମ୍ ସମାନ, डिफरेंट इंस्टेंट रे मोशन स्टार्ट करते ऑसिलेशन स्टार्ट करते फिर भी ऑसिलेशन को मेंटेन करि पारते समान समय रे यार मैक्सिमम लुक एट हियर टाइम पीरियड फॉर बोथ द केसेस आर सेम ओमेगा नॉट इज सेम but different instant they are producing this motion. Okay, you can think about this, is it possible or not, analyze yourself. Now come to a more critical case. In your exam, whether it is JEE Main, JEE Advanced, sometimes honors classes, honors exams, university exams, this question is frequently asked. Now you have to choose our two simple harmonic oscillators. They have different time periods. Different time periods having same A and theta. Same A and theta. Amplitude and at the instant they start oscillating same. Same amplitude. Both the oscillators have same amplitude. They started motion at the same instant. But look at the time period. Again, I draw here xt graph. First one is something like this. Amplitude is A. Here. This is our oscillator A, fast oscillator. And here, motion repeats here, very same, like this. Like this. Here is our TA, one complete oscillation. Motion repeats here. This is our one time period. Let's look at the second oscillator B. Same amplitude. So here, this oscillator also have same amplitude starts here, and same instant it also starts here. At the same instant it starts. You look at here. Same amplitude. At the same instant here. How much time period? Just look at this picture and keep quiet, think about it. Let it bhaba base. Here time period kale 80 pile here B. This oscillator is our B. Second one is oscillator B, and this time period is TB. Look at here, 2 TB, 2 times. Data cycle play here got a cycle. Here is our one cycle. Here is another cycle. So 2 time period, 2 TB. What have you seen here? Same amplitude, both the oscillators have same amplitude, started motion at the same time. But if you look at these two time periods, you can get the conclusion TA is equal to 2 times TB, or it may say TB. Oscillator B has a time period half of that of A. Pause somewhere, sometime, pause for some time. It's some time. How is it possible? How the motion started? So that one oscillator covering the distance having time period TA, and second one oscillator B covering the same distance having twice the time period. How is it possible? You may think about this. These are the beauty of our some data about amplitude we have collected. Now let's proceed towards velocity. I think up to this point you people must have clear. ଏଇଠି ପିଲେ ବହୁତ ସମୟ କ୍ୱେଶ୍ଚନ୍ ପଚରାଯାଏ ଯେ ଏମିତି ଦୁଇଟା ଗ୍ରାଫ୍ ତୁମକୁ ଦେଇଦେଇଥିବ ଏବଂ ଟାଇମ୍ ପିରିୟଡ଼ର ରିଲେସନ୍ ପଚାରିଥିବ, କାହାର ରିଲେସନ୍ କ'ଣ ହେବ? ମଲ୍ଟିପଲ୍ ଚଏସ୍ କ୍ୱେଶ୍ଚନ୍, TB equal to TA/2, TA equal to TB, TB equal to TA, which two options are correct? More than one option correct वाला क्वेश्चन एमती पचरा जाए पारे. Very important one. question must come here. बहुत मन बुझिपारथिबो. Let's proceed towards velocity. Velocity. Look, velocity. Velocity. How can you get velocity of the oscillator? Simply, velocity is our dx upon dt, dx by dt. So it will be ddt of x of t is how much? A cos theta plus omega naught t. You can differentiate. मास्टर तुम निश्चित है तुम माने डेरिवेटिव सीखी थी वो माने डेरिवेटिव करी परिवार so डेरिवेटिव होगा कहते पहले minus a omega naught sin theta plus omega naught t this much minus a omega naught sin theta plus omega naught t. Or simply you look at here our cos theta plus omega naught t will be x by a. X by a. It is x simply x. X always function of time. Simply x write it. X by a. So that our sin theta plus omega t will be how much? Sin theta plus omega naught t will be how much? 1 minus cos square theta plus omega naught t square root. It will be root over of 1 minus x square by s square. X by a whole square, x square by square. So you come here. It will be minus a omega naught sine of this much is the root of square root of 1 minus x square by s square. It will be minus omega naught square root s square minus x square. Square root of s square is a, and this a will cancel out. This will be our final result. Okay? Velocity is how much? Minus omega naught root square root s square minus x square. Let's try to find the velocity of oscillator at different positions. Basically, two positions are very important. This is our velocity expression minus omega naught square root s square minus x square. बुली गले जमारू very important बोले बहुत समय काम राशि को आगे तो एनालिसिस करिया. Start at x equal to 0. That means at our mean position, this velocity will be how much? Minus omega naught square root s square minus 0, which is equal to minus omega naught a maximum. So velocity will be maximum at mean position. Very clear here. A is our constant, omega naught is constant, V ultimately depends on x. When value of x decrease, ultimately this one will increase, so V will be more. If value of x increases, this one you are subtracting, it will decrease, the velocity will decrease. Example, x equal to a बगे दबा, at x equal to a plus or minus a, at x equal to plus or minus a. That means our extreme position. Plus a this side, plus a x equal to 0 here, plus a here, minus a here. So at x equal to plus or minus a, our v will be minus omega naught square root s square minus plus or minus a square, which is minus omega naught square root s square minus a square, which is 0. This is our minimum value of velocity. At least you should get some idea at which position our velocity of oscillator will be maximum and at which position our velocity of oscillator will be minimum. So at extreme positions velocities are minimum and at mean position velocities is maximum. This thing you should put it in your mind, don't forget it. बहुत काम से आगे को भूलिबनी. Now let's proceed towards acceleration. acceleration play A equal to dp by dt, which is equal to ddt of B is our minus omega naught A sin theta plus omega naught t. Just again बाहर कर ले, just some time ago we have derived this velocity. It will be how much? Minus omega naught A derivative प्लस एक जो आगे omega naught ऐसे हो तो ये जो omega naught square A cos theta plus omega naught t, and this A cos theta plus omega naught t is our solution of the differential equation x. So minus omega naught square x. This is our acceleration. This is our acceleration. Minus omega naught square x. And you know, you must have remembered omega naught square is our k by m. That means a constant. So that means acceleration proportional to displacement and acts in a direction opposite to that of displacement. This is one of our basic definition of simple harmonic motion. Acceleration is proportional to displacement and acts in a direction opposite to that of displacement. Now you can easily locate the value of acceleration for the oscillator at different positions. At x equal to 0, at x equal to 0, at our mean position. Not always x equal to 0 is our mean position. For the betterment of our calculation, we may assume this. X equal to some other value may be the mean position in some other cases. Let's choose x equal to 0 is our mean position. This position, x equal to 0, this is x equal to plus a, this is x equal to minus a. X equal to 0, at x equal to 0, a will be how much? A will be 0, simply x 0 means a 0. So acceleration will be 0 at mean position. Obviously, we look at here, suppose this is your x equal to 0, this is mean position, this is your extreme position, and restoring force starts here. Here restoring force starts. What is the role of restoring force in simple harmonic motion? It simply retraces the oscillator towards its mean position. एते क्यों तार काम एक्सट्रीम पोजीशन लाने मेन पोजीशन ला छाड़ियो मेन पोजीशन ला छाड़ी साला पर काम भी सरी वाला. So restoring force will be 0 here. If restoring force is 0 here, restoring force का काम दिया एठो आनी वेट छाड़ी restoring force is 0. Restoring force 0 होगा न्यूटन सेकंड ला अनुसार F equal to ma, so ma is equal to 0. Here m cannot be 0, so a is equal to 0. Acceleration should be 0 there. And where will be acceleration maximum? Acceleration will be a maximum होगा जो restoring force maximum होता. That means at x equal to plus or minus a. At x is equal to plus or minus a is our extreme position. Our acceleration will be how much? Minus omega naught square a. This one. This is our maximum value of acceleration and this is minimum value of acceleration. Clear? Acceleration is simply you can get the expression for restoring force here. If you multiply m here and here, ma is our force. Restoring force is equal to minus m omega naught square. M omega naught square is k minus sin is there k and x. This is the expression for restoring force. Simply multiply m throughout. You get this expression. It's very easy. Now come to where? Come to our mechanical energy of the oscillator. As you know, you may take the example of spring mass system or thread ball system, simple pendulum system, spring mass system. These are all mechanical systems. When they execute simple harmonic motion, they must have produced mechanical energy. That means both potential energy and kinetic energy. So let's first find kinetic energy. This is our mechanical energy, total energy. We are going to find out this total energy. Let's first calculate kinetic energy. K. Kinetic energy K. Sorry for disturbance. Kinetic energy K will be how much? K is our half mv square, half m. V is our, just remember here I have written minus omega naught square root s square minus x square. This is the expression for V. I told you, don't forget this, very important. This is square, this square. So half L omega naught square into a square minus x square. Square root plus square, this much. This is our kinetic energy. And you can locate the positions where kinetic energy will be maximum and the positions where kinetic energy will be minimum, and also you can locate the positions where kinetic energy value is in between this maxima and minimum. Okay, so see, let's find maxima and minimum at x equal to 0, as it is always is our mean position. What will be kinetic energy K? Half m omega naught square s square. You look at here, if x increases, this subtraction, you are subtracting s square minus x square. X square is subtracted from s square. If x will increase, this value will decrease, so kinetic energy will decrease. If x will decrease, for x equal to 0, remember, if you take x equal to negative, it will add you square means positive result, that means it will decrease. Only result x equal to 0 is the minimum result. Half m omega naught square s square. This is our maximum kinetic energy. Okay, and at x equal to plus or minus l, that means our extreme position K will be how much? Half m omega naught square s square minus plus or minus r square. Plus r square is s square minus r square also s square, so it is 0. Where? At extreme positions. You look at here, your oscillator simply moves here and temporarily rests here. So V equal to 0 here. ठीक है, अगर वो डिस्कस करते हैं V एक 0 बोले तो V 0 मीन्स kinetic energy half m square, kinetic energy is V जो maximum, kinetic energy is maximum. V ये जगह पर maximum होगा, kinetic energy जगह पर maximum. Look at here. At mean position our kinetic energy is maximum. At extreme positions our kinetic energy will be 0. Okay, can you say how many times our kinetic energy will vary in one complete oscillation? Just look at here. You can fix your attention to at any one position so that you can answer this question more precisely. Suppose this is our mean position and you fix your attention here. Oscillator starts here, comes here, going here, then return, then come here. So when it starts here and it reaches here, one time kinetic energy will maximum. And when return from here minus a side and again reaches here, also its kinetic energy will maximum. So how many times your kinetic energy will vary in one complete oscillation? It's 2 times. 2 times kinetic energy will vary, both maximum and minimum. Both maximum value and minimum value of kinetic energy will vary twice in one complete oscillation. You just remember these values. Kinetic energy value is half m omega naught square s square minus x square. Kinetic energy maximum value, remember, kinetic energy maximum value is half m omega naught square s square. Don't forget this, it's very important. Now find potential energy. Potential energy ପାଇଁ के लिए ମୁଁ ଫର୍ମୁଲା यूज କରୁଛି potential energy ପାଇଁ बाबू से फर्मुला समान जानितो हाफ ए एक्स स्क्वायर यदि जानि ना हो तो फर्मुला बहुत इजी जेतो पिला ऑसिलेटर एक्सट्रीम साइड रे थिबो एवं रिस्टोरिंग फोर्स 8 पडुथबो ऑसिलेटर को मेन पोजीशन को आनिया ପାଇଁ तो ऑसिलेटर रे 8 पे मेन पोजीशन को आसीबो रिस्टोरिंग फोर्स किछ वर्क करूथबो ऑसिलेटर को मेन पोजीशन को आनिया ପାଇଁ ये जो वर्क करूथबो इसे सिस्टम रे ऑसिलेटर रे पोटेंशियल एनर्जी का स्टोर है. So the restoring force कितना वर्क करे for very small displacement dx work done will be your dw is equal to fr dot dx and for x how can you will just do the integration dw integration w and fr dx you always know fr in this side, this is the direction of fr, this is the direction of dx and look at here. This is your direction of fr and this is the direction of dx. A very small dx. So angle is 180 degrees. So minus fr dx. Fr dx cos 180, cos 180 is minus 1, minus fr dx. So minus fr value is minus kx and dx. So minus 1 is plus and the integration kx dx. K is constant, k bring outside x dx integration is x square by 2 x square by 2 so it is half kx square. This is the formula. This work is stored in the system as the potential energy, so half kx square and you know the value of k is m omega naught square half m omega naught square x square. This is our potential energy. Let's say E and at x equal to 0 mean position. At mean position, this u will be how much? Half m omega naught square into 0. That means 0. So at mean position, potential energy is 0. But at mean position, just we have analyzed. At mean position, our kinetic energy is maximum. Potential energy is 0 there. And at x equal to plus or minus a extreme position u will be half m omega naught square x plus or minus a square, that is a square. This is maximum. This is maximum. This is minimum. So what have you seen here? The position where our kinetic energy is maximum is the position of potential minimum potential energy. जो जगह पर kinetic energy maximum होतला से जगह पर potential energy minimum होची, जो जगह पर kinetic energy minimum होतला से जगह पर potential energy maximum होची. किसी तो कोई रिलेशन अच्छी जिसमें कि एमती किसी इंडिकेशन आसुची सूचना मिलुची. टोटल एनर्जी T it is K plus E. Kinetic energy plus potential energy, kinetic energy is our here half m omega naught square s square minus x square plus potential energy half m omega naught square, it will be half m, we cancel half m omega naught square, sorry u is half m omega naught square x square, cancel half m omega naught square x square, cancel half m omega naught square s square. This is our total energy of the oscillator. All are constants. R is constant, m is constant, omega naught is constant, a is constant, all are constants. So total energy of the oscillator in simple harmonic motion always remains constant. That means law of conservation of energy holds good in our simple harmonic motion. How can you know this? Very easy. Here you can look. Where potential energy is 0, there kinetic energy is maximum. Where potential energy is maximum, there kinetic energy is 0. That means there is a correlation between this potential energy and kinetic energy. Always kinetic energy transferred into potential energy transferred into kinetic energy. Which is one the play? Let's see. Suppose oscillator starts here. Here is our extreme position. It oscillates like this. Here is our extreme position. V equal to 0 here means kinetic energy 0 here. That means potential energy is maximum here. When it comes to this mean position, the oscillator mean position कैसे हो? धीरे 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 kinetic energy 0 8 के लिए थिला. धीरे धीरे kinetic energy बढ़ी हो with the expense of potential energy. That means you can say that potential energy is transferred into kinetic energy. Potential energy is converted into kinetic energy. Potential energy ही kinetic energy convert है एक आस्तो. तो ये जगह पर कौन है जो बोले kinetic energy maximum है तो potential energy 0 है तो. And here to this side kinetic energy slowly decreases and potential energy slowly increases. That means from here to here, this mean position to this extreme side, kinetic energy is continuously converted into potential energy, and at the other extreme side, our 1 second kinetic energy will be 0, potential energy will be maximum. Clear? बुझेला बोले? मोशन एट स्टार्ट होला, 80 वेलोसिटी 0, 80 kinetic energy 0. मतलब मेन पोजीशन कैसे हो kinetic energy 0 थिला धीरे 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 प्ले kinetic energy gain होगा लगला केमती gain होला potential energy ही kinetic energy convert होला at any position you may take कौन सी पोजीशन प्ले तमे नियो total energy always remains constant कौन से पोजीशन ले kinetic energy जति कमी थियो potential energy सेति बढ़ितो यदि एमिति पोजीशन में पाउछो जो kinetic energy 0 हे छि पक्का से potential energy total energy हे जो potential energy 0 होछि सेति total energy पहले kinetic energy को बुझिया जो kinetic energy 0 होची फिर total energy कहले potential energy को बुझिया. I think this thing must clear. No doubt. If any doubt arises, you can comment me in the comment box. I will try to answer your questions. Okay? यदि पहले कौन सी मन प्रश्न आसुता है, you can ask me without any hesitation. So one thing you may have observed. The maximum value of kinetic energy half m omega naught square square. Maximum value of potential energy also half m omega naught square square. Total energy half m omega naught square square. That means जो जगह पर potential energy maximum हबो सेठी kinetic energy 0 हबा को बाध्य so that total energy अधिक रहियो. Otherwise conservation of energy principle जोटा कि physics रो नेचर रो नियम प्रकृति रो नियम भावरेट करियो काम करियो प्रकृति रो नियम त काम करियो पड़ियो. तेणु जो जगह पर पोटेंशियल एनर्जी मैक्सिमम हम से किनेटिक एनर्जी पक्का 0 हो 0 हेले जे टोटल एनर्जी मु सेत में तुम कहली जो पोटेंशियल एनर्जी मैक्सिमम हो किनेटिक एनर्जी 0 हो एवं टोटल एनर्जी कहले केवल पोटेंशियल एनर्जी को बुझाओ जो जगह पर किनेटिक एनर्जी 0 हो पोटेंशियल एनर्जी मैक्सिमम हो टोटल एनर्जी कहले पोटेंशियल एनर्जी को बुझाओ जो जगह पर पोटेंशियल एनर्जी 0 टोटल एनर्जी किनेटिक एनर्जी जो जगह पर किनेटिक एनर्जी 0 टोटल एनर्जी कहले पोटेंशियल एनर्जी. Clear? So that's all for today. In my next lecture, I will show you the variation of kinetic energy and potential energy with position as well as with time. I will draw two graphs. I will plot two graphs. दुटा ग्राफ के लिए ड्रा करेंगे. दुटा ग्राफ very important परीक्षा पॉइंट ऑफ व्यू रे. तो मैंने प्लस टू लेवल ही पढ़ा था. पक्का क्वेश्चन है आसे. जेई में लेवल क्वेश्चन आसे. ते एडवांस लेवल आसे. ऑनर्स पास प्लान तो निश्चित हो रहा है. So very important. Don't forget this to watch my channel. Next time I will discuss about variation of kinetic energy, potential energy with distance as well as time. तो भल लगुव चैनल को सब्सक्राइब करिवो लाइक करिवो शेयर करिए सो दैट अन्य पिला माने जानिले बेनिफिट नहीं पारिबे. Okay, so that's all for today. Stay tuned for our next video. Thank you for watching.